So this is practice set 2. We're going to go through all the problems. Now number 1 is asking us to find the frequency, and we have 12 waves in 3 seconds. Now the frequency is the number of waves in 1 second. So if we have 12 waves, now waves does not have a unit. There's no unit for one complete wave, so it has nothing next to it, but it is in 3 seconds. So that gives us 12 divided by 3, which is 4. Now our units would be 1 over seconds, because there's no unit on top, which is called a hertz. So it's 4 hertz. And that is our answer to our first one. Our second one asks us about the period. Now it's the same information, 12 waves in 3 seconds, but the period is the inverse of the frequency, which means they're flipped. Now I have 3 seconds for 12 waves. Now remember, there's no unit for waves. And 3 out of 12 is 1/4. You see, it's the opposite of this answer before. And that is seconds on top. And there's no unit, remember, for waves, which gives us 1/4 of a second is 0.25 seconds. That is our answer number 2. Now the next answer to that is that, like I said earlier, frequency and period are inverses. If you don't remember what that is, if I have A, the inverse of A is 1 over A. Alright, so number 3. A wave has a frequency of 50 hertz. So this is what is known. Right? I have a wave of 50 hertz and a wavelength of 10 meters. What is the speed of the wave? Our equation is going to be, the speed equals the frequency times the wavelength, which for this case is, or let me do it on work. Solution. Our speed equals our frequency, which is 50 hertz, times 10 meters, which we know is 500. Now, the unit of hertz, like we said earlier, was 1 over second. So this is actually 500 meters per second. And that is number 3. Number 4 asks us for some red light waves have a frequency of 442 hertz. Now, our known is our frequency so far, 442 hertz. And it has a speed of 2.99 times 10 to the 8 meters per second. This is actually the speed of all lights and all electromagnetic waves. So now let's move on. We have our equation, which was, again, speed equals frequency times wavelength. But this time we need to move it over so that we are solving for wavelength, which means that we'll have our speed divided by our frequency. That will be our wavelength. So this is the equation we'll be using. Solution is, so we have wavelength equals our speed, which is 2.99 times 10 to the 8 meters per second, divided by 442 hertz, which, remember, we said 1 over second. Now, we have to go to Desmos to plug this in. Desmos. Now I have, remember to use parentheses to keep everything together really neat. So we have 2.99 times 10, our exponent, to the 8. And we'll make sure we'll switch over and close the parentheses. Now we'll divide it by 442 hertz. Now that gives us, go back, 600, that's a big number. It is, let's see, 676,470.588
Like 588. Oh, sorry.
So that is 676, 470.588. Now, these seconds cancel and we're left with meters. Now, if we move this decimal over, we can find this in scientific notation. So at 6.76, I'm going to just keep it up to these two decimals. And since this value is a 4 and it's not above a 5, this 6 is, we're not going to round. We're going to leave it how it is. Now, I move this decimal over 1, 2, 3, 4, 5 times. So it's times 10 to the 5 meters. And that's number 4. Number 5 says a violet-red light wave has a wavelength of 4.15 times 10 to the negative 7 meters. So our known so far is this wavelength, and it's 4.15 times 10 to the negative 7 meters. And we also have a speed of, again, it's light, so it's 2.99 times 10 to the 8 meters per second. What is the frequency of the wave? So our equation again is going to be speed equals frequency times wavelength. But we're looking for frequency. So we move this, we divide by the wavelength, and we get frequency equals speed divided by wavelength. Now, our solution, I'll write down here, sorry, it's at the very bottom, is going to have the frequency equals the speed divided all by the wavelength, which was 4.15 times 10 to the negative 7 meters. These meters were canceled, we already see that. And we can once again go to Desmos to plug this in. Now let's clear our previous answers. And using parentheses again, we have the speed on top this time, 2.99 times 10 to the 8. And then move over and put our parentheses, and we're going to divide by, again, parentheses, 4.15 times 10 to the negative 7. So exponent, negative 7, parentheses, again, and we have 7.2 times 10 to the 14th. So that's already in scientific notation, so we need to put it 7.2 times 10 to the 14th hertz. We see that we're left with the second right here, which makes it hertz. Now, our last problem is number 6. It says, an observer notices that an ocean wave has a speed of 2 meters per second. So you must have been counting that in a second there was 2 meters passed by. Now, they also measured the wavelength, which was 3 meters. That's his meters. What is the period of the wave? So we're looking for the period, which is denoted by this big T. It's our question mark. So now we have our equations. Now, we know this equation for speed. And for our time period, we see that it is 1 over the frequency. Now, we can solve for this and then plug it in right there. So let's see, we know the speed and the wavelength. So now we can say frequency equals 2 meters per second divided by 3 meters. These meters will cancel out again. And we get 0.67 hertz. Now, to finish this off, we're looking for the time period. And that's going to be 1 over the frequency, which is 1 over 0.67, which is about 1.5 seconds. And that concludes our video. Thank you for watching.